So we've should be reasonably familiar now with the premise of XCM and some of its some of the language idioms, how we get certain things done. Now we're going to look even more concrete and see how XCM and the rest of Frame interact. So there is an XCM palette. So XCM itself, like if you go all the way down to the actual language definition, it's got very, very few dependencies, right? And as you get more and more concrete, like the XCM executor, then we have the XCM builder, and finally the XCM palette. The XCM palette has a lot of dependencies, brings in the language, of course, but it brings in all sorts of stuff to do with Frame and that. So this is basically the highest, sort of highest level XCM piece. And it deals with a lot of the operational necessities of practical XCM use. So we're going to look at the XCM palette itself, but in particular, we're going to look at how some of the things that it does work. Now, I don't want to get too deep into this, into the mechanisms that it uses. I think it's worth knowing it just so that you understand how practical XCM systems work and how and what's going on sort of under the behind the scenes for things that you are likely to be using. But you don't really need to know all the ins and outs about how Palette XCM works. To a large extent, it's a facility, and how it works is more of an implementation detail. But I think it's worth knowing a little bit of it because you know, if you're going to be using XCM, you're going to be building on top of XCM. It's worth understanding how some of the more sophisticated systems that use XCM have been designed. Right, so yes, it's the thing that XCM or the XCVM subsystem and Frame is how they interact. Frame is our operational framework for on-chain logic. Yeah, it's where all the on-chain logic sits. Any part of XCM that's going to be using on-chain logic needs to have a footprint in Frame in order to make sure that logic gets executed. Some of the XCM palette is to do with execution of messages, maintaining kind of routing primitives and queues and stuff. But I'm not going to talk too much about that. I want to talk about some of the more some of the things a little closer to the surface. Now we come to an important point. XCM isn't really something that we expect end users to be writing, right? At the end of the day, it's kind of like a scripting language or a programming language. You don't expect end users to do coding for you, right? No, it's something that we would expect developers to be building with and packaging things up in discrete forms for their users to work with. So like something that you put in a palette perhaps, or maybe at a push in the front end, but not something that you expect users to be sort of bashing out themselves. This would be a bit weird. So what does Palette XCM do? Well, there's a bunch of stuff. Two of the more important ones are sending XCMs, like executing XCMs locally and sending XCMs to somewhere else to be executed there. We provides an easier interface for transfers. It's not the only way of getting transfers done. There is a, you know, if you look in ORML and another sort of Frame palette library, you'll find palettes there that do this too, but this is one way of doing it. It's the way that comes within Substrate. And there are certain XCVM stateful duties that Palette XCM provides implementations for. Now, the XCVM is written to be independent of frame. And if you look at XCM Executor, which is the XCVM implementation that comes with Substrate, comes with Polkadot SDK, rather, then you'll see that it doesn't bring in any frame stuff itself. But it provides traits that need to be implemented in order to provide certain functionality to the XCVM. Functionality that I'll cover now. But some of that is, for example, version negotiation and claiming potentially lost assets, getting assets back. All right, let's look at execute. So there's a dispatchable called execute, takes an XCM, and it basically just fires up the executor and executes it. Pretty simple proposition, really. The origin it's executed with is a sort of XCM origin version of the frame's signed origin. So XCM has an account ID 32 node that you might have seen in some of the earlier slides. Basically, it's just wraps the signed origin in an account ID 32, and that becomes the XCM origin. Yep. Okay, that's execute. Very simple. Send basically does that, but on another chain, in another location. So it sends. You give it an XCM, but you also give it a location. And then it basically, Pallet XCM delivers it via the XCM router into an outgoing message queue. Usually, there's a chance that it just gets delivered straight into Parity. If the destination is the same as the current location, then it might just go into its own message queue. But usually there's two message queues involved. There's the outgoing message queue where it's like queued to be sent out through XCMP, HRMP, UMP, DMP, bridges, whatever. And then there's an incoming message queue at the destination side where it's queued to be executed. And then eventually it gets around to being executed. Okay. So there's obviously a bit more latency here because you've got message queues and potentially other stuff that's the message transport protocols. But it gets there eventually. It gets executed. Yep.
So does the actual XCM instructions or like live on the block anyway or anywhere, or just it's like each node will be having their own message queue and sending them to like what happens exactly here?
Each node. No, the message queues are on chain.
On chain.
All of this logic is on chain.
Yes.
XCM never leaves chain.
Yeah.
It's all in consensus. Good, right. So familiar with the cross-consensus asset transfers, right? The two models, teleporting and reserve-backed. So we have in Pallet XCM this, it's called limited teleport assets. The limited thing is don't have to worry about that. You can think of it as teleport assets. It's just like an older version of the function as teleport assets. So we had to put this extra limited dash in before it. But basically, you give it a destination, a beneficiary at the destination, what assets it is that you want to teleport. You identify one of these assets as the thing that you pay the fees from, and then you give it a weight limit potentially. And then it basically makes a program, an XCVM program, and executes it that will ultimately send a teleport instruction to the trusted destination. You don't really need to care about the fact that it makes a program. It's how it works internally. But all you really care about is that some assets appear at the destination, like the right assets appear at the destination, and indeed they do. So there is that. So it's like easy teleports. And there's similarly an easy reserve asset transfer, dispatchable that you can use. This works in more or less the same way. There's, I think this is new.
Yeah, this is new. Yes.
This is new, right? Yeah. So there's a new thing. It's come in the last 6 months that does both, depending on what the destination is. So if it's a destination that is trusted for this asset to be teleported onto it, then it uses teleports. If it's a destination where we have a reserve location for the asset, then we use the reserve. And I guess it fails if there isn't either. Good. So, version negotiation. I mentioned XCM is versioned. So when XCMs get sent between chains, they're actually packaged up. It's not just the back of instructions. There's an extra thing at the beginning that tells the destination what version of XCM is following, right? The way it actually looks is very simple. It's just an enum, right? Very, very simple. And you've got a few different types of XCM, version 3, version 4. It's a little bit more complex than this, of course, because we have to put the codec stuff in here to make sure that it encodes these variants correctly, but so it's more or less it. Now we use versioning in order to ensure that when the destination receives an XCM, it's of a version that it can understand. If we are at version 4 and we receive a version 3 XCM, it's probably fine because we probably understand any version before. But if we are at version 3 and we receive a version 4 XCM, then it's a bad thing because we probably can't even decode it. So it's important that there is a negotiation between the endpoints to find the lowest common version that they support. Yeah, and Pallet XCM does this. It can do this for you. It does it more or less automatically as well. It turns out that there are 2 instructions. Well, you've already seen the query response. We covered that a little bit earlier, right? There is also a subscribe version instruction. What subscribe version does is it sets up a little bit like with JSON RPC pub/sub thing. It sets up a subscription to the destination chain such that whenever its version changes, whenever it gets a new version of XCM, it sends a query response back with the same query ID as what we tell it to here. So we give it a query ID in the subscribe version, say like, I don't know, 42, along with some max response weight, which is basically the weight that we need to provision in order to process this message. Yeah. And what happens at the other side that Pallet XCM cunningly looks after is it sends a query response back with its current XCM version, which is in this response item here. And then this max weight is just the same as this. And this query ID is the same as this. And then whenever that chain's XCM gets upgraded, whenever it gets a new version of XCM, it sends another query response back with the new XCM version in the response. Yep. And then the chain that sent the subscribed version in the first place, just actually in its Pallet XCM has a map that just maps out which version each of its destination chains are on. And when it wants to send a message to one of those destination chains, it checks the version and it lowers the version of XCM that it encodes with to that version. Yeah. So if it's at version, well, let's have a look. I think we've got an example coming up. So in this case, we have this map which Pallet XCM maintains. It's like Pallet XCM on chain A might be at version this must be old. This must be v4. Because there's no way it could send v3 to chain E. but that has to be at least v3 or 4. I'll alter it. Sorry. So we've got, yeah, it's got a registry, chain A, chain B, chain C. Chain A wants to send a message to chain E, so it has a look at chain E, it sees it's at version 3. Now suppose chain A is at version 4, then it's going to choose the lower of the two, version 3. What it's going to do is it's going to take its version 4 message and it's going to translate it into a version 3 message and then send that. So higher versions of XCM can generally be translated into lower versions of XCM. Now, of course, there are times where a message cannot be reformulated in a lower version. Maybe a new instruction was added, right? In these cases, message sending fails. If you can't reformulate a message such that it's sensible, makes sense to the receiver, it just comes back with an error. Straight away, as part of sending, before it even gets to the point of enqueuing anything or anything like this. So, right. So we have, when we set up our XCVM, indeed, here we are. This is setting up the XCVM. We have a couple of configuration types. Response handler, the thing to do when we get a query response. What do I do with a query response? It doesn't know what to do with a query response. So we have a response handler and a subscription service. What do I do when someone says subscribe version or unsubscribe version? Right? It doesn't know what to do. Like the machine itself doesn't know what to do with these kinds of things because it doesn't have any state. Right? It's not interacting with frame. It doesn't have any kind of maps or storage or anything like this. It can only do this kind of register processing stuff. So for all of the stateful stuff, it has to be configured. And so it has these two configuration options specifically for version. Well, actually, this one is specifically for version subscription. This is a very general one for handling query responses. They can both be set to Pallet XCM. You can, of course, set it to your own thing if you want to change the default behavior. But yeah, for basic usage, Pallet XCM should be fine. So yeah, response handler manages what happens when it receives a query response instruction, and subscription service handles what it does when it receives a subscribed version or unsubscribed version instruction. That's just saying that. Yeah, so this is the automatic bit. If we try to send a message to a destination and we don't know what version it's on, and we don't have a sort of safe version that we've already put in place, then we basically don't send the message because we don't know how what version we should be sending it with, and we basically queue it up for discovering what version it's at. And that involves sending a subscribed version. Yeah, and then the message can be resent once we've discovered what version the destination is on. So this only happens once, only at the beginning of talking to a new destination. There is a plan to change this so that, because we are channel based with XCM, or at least with HRMP and bridges and things, to change this so it happens as soon as the channel is opened rather than just before the first message gets sent, which makes a lot more sense. But that's not how it's done at the moment, so it's a bit of technical debt that needs clearing up. Okay, so when we're doing version negotiation, chain A will send subscribe version to chain B will respond with a query response, say, hey, this is the version that I'm at. This then gets processed by chain A's query responder thing in Pallet XCM, its query response facility in Pallet XCM, which basically sees that it's a response to its version subscription message and stores the supported version. B then does the same thing. It wants to know what A is on, so it sends its own subscribed version. A then replies to B. And then once they both know what version they're on, they can proceed with communication. And of course, this gets updated as either one updates their Pallet, their XCM mechanism, their XCM version. Been over that. So yes, version negotiation is only one of the ways that you use query response. There are many, many ways of using query response. And Pallet XCM provides a fairly general purpose way of managing these responses. Basically, the responses will, if they are recognized, that there's a way that you can sort of tell Pallet XCM, hey, I'm sending a query out, this is the ID, and it's got this amount of weight that I'm expecting it to be processed with. Let me know when I get a response, or do this when I get a response. And there's a way of doing that. Now, we don't really have callbacks in Frame, right? So we can't use typical asynchronous programming mechanisms, because callbacks would imply saved sort of some degree of continuations being saved between over many blocks. We don't have continuations over many blocks. Like, it's just not a thing. It may become a thing with some of the stuff that CoreJam enables, but it's not a thing at the moment in Frame. And so the closest thing that we have are dispatchables. So what we can do is we can give a dispatchable, basically like an extrinsic, that gets called when a query response comes in that matches a certain thing, i.e. has a particular query ID, for example. And this you can already do. So you can say, I'm sending out this this message, or I'm making an instruction that will result in a query response coming back. Set things up so that this dispatchable is called when that response comes in. Sort of like a kind of a bit of like a callback, but a sort of one that can span many blocks. Now, of course, if you do a runtime upgrade while this callback is pending, and the meaning of that callback changes, then you're kind of screwed. So you've got to be a bit careful with using this kind of callbacks. The rule of thumb is always ensure that with a runtime upgrade, if you're upgrading your pallets, either there are no callbacks happening, pending, or if there are, make sure that your whatever a callback, whatever extrinsic, if it's encoded on the prior version, make sure that encoding means the same thing on the posterior version, which basically means kind of semver style, only ever add to the API, don't change or remove from the binary, the ABI really, the binary API. Yeah. So if an extrinsic, and if an encoded extrinsic means X, make sure it always means X after upgrading, or that you don't have any callbacks that might have that extrinsic in them. Otherwise, you risk doing the wrong thing when the query response comes back. Now, that's not the only way you can use Pallet XCM to handle query responses. You can also not give it anything specific to do and just use a polling mechanism and just say, hey, did you receive a query response for this ID? And just do this every few blocks or something. This is also another way of doing it. Internally, it's all Pallet XCM does itself, right? It just checks basically when a message comes in. Actually, that's not quite true. When a message comes in, it will check to see if it's got a handler. If it has a handler, it will call it. If it doesn't have a handler, it will handle it itself by putting it in a map, as long as it's expected. If it's not expected, then it could be that it's just, some chain trying to grief it, or just going mad and sending it responses to the wrong place. In which case, we just drop them. If we're not expecting them, we just drop them. So yeah, I kind of covered this earlier, but I think it's probably worth just covering it once more. XCM is not fundamentally symmetrical, right? There is no assumption that its underlying channel provides a sort of return path. However, it's not unreasonable that a return that a return path exists, or that it's possible to send a message in the opposite direction. This is not an unreasonable expectation. It's just not one that we rely on, because we can imagine situations where only one path exists. So we don't rely on it, but we do provide for it. And query response is how we provide for it, by and large. So when we use query response, we have this query response info. This is usually passed in to the instruction that is that will get a query response back. So it's sort of what we pass along into a destination chain that we expect a response back from. Yeah. So we tell it where it should be sending the response to. This is the destination's destination, which is the source. We tell it what the ID is that the query response should have. Yeah. We need an ID to recognize, tell them apart. And we tell it how much weight it should execute when it's processing the response, how much it should execute with. If it's just putting it in a map, like if it's not doing anything particular with it, then this will just be some fairly fixed weight. That's whatever Pallet XCM thinks it should be for putting it in a map. If it's got an extrinsic to execute, if it's got like a callback or a handler associated with it, then this max weight will have to be whatever the maximum weight that handler could use is. And this will be checked as part of Pallet XCM. Good. Yeah, that's basically it. So querier is that initiator of the query response. So the original sender, the one that presumably the query response is being sent back to. Query ID we know, and the max weight we know, and then the response is actually the response, the information that we are responding with. Right, that brings us finally to asset traps. Asset traps are added in, I think, XCM 3 as a way of helping prevent the loss of assets in unexpected circumstances. Now, ideally, XCM never, when you're doing XCM, you don't encounter unexpected circumstances. But, unfortunately, we live in the real world, and not some perfect thing that we can expect, have absolute expectations on. And so things can go wrong. And so we need these sorts of things, these sorts of error handlers and whatnot. So I've already covered the set appendix, set error handler. That's one way of managing unexpected situations. This is a sort of fail-safe if even those don't work. Asset trapping. Basically, as I mentioned when I introduced the holding register, it's ephemeral. When the program stops executing, the holding register vanishes. Yeah. If it's got assets in it, those assets will no longer exist. They're not going to exist on chain, because as I mentioned earlier, for an asset to get into the holding register, it usually means it's been removed from an on-chain state. Yeah. Asset trapping is the exception. When a program terminates with something in the holding register, there is a process, asset trapping, which places or attempts to keep that asset around for a while, puts it back in state. Now, what it doesn't do is put it in any particular account. This could lead to a little bit too much. This could lead to effectively unbounded weight usage, which we don't want. What it does is it puts it in a special part of Pallet XCM state, and Pallet XCM doesn't store the asset in a sort of on-chain native way. It stores it in an XCM native way. It actually stores it as an XCM asset, how XCM would store assets, using the data structures that I showed you earlier. So it doesn't try and interact with any of the pallets. That's what I'm trying to say. So if you're using assets palette or balances palette or any of the other palettes, it doesn't have anything to do with those. What it does is basically just snapshot what's in the holding register and keep it around, along with the origin. And then at some later stage, the origin can send a message that says claim assets. And what that will do is check if there has previously been a sort of one of these snapshots attributed to its origin. And if there has, it will be cleared and the assets will be placed back in holding. Yeah. So it's sort of like a holding register snapshot and restore function. And it happens automatically. You don't need to do anything special. I mean, the chain has to be configured for it to be enabled, but you as the XCM programmer don't have to do anything special. Now, it doesn't make sense to trap all assets, because otherwise you could make a worthless asset and then just continually make programs that leave one of them in the holding register at the end of the program and just bloat this bloat Pallet XCM state indefinitely. That's no good. So usually, and the way that you would configure the asset trap mechanism of Pallet XCM is to specify which assets are worth keeping, are worth snapshotting, and which assets are not. Yeah. So you basically specify a filter condition, and it basically says if anything in the asset trap in the holding register fulfills this filter condition, then we trap it. If it doesn't, then they just get dropped. They're not worth anything. Yep. And that allows us to put thresholds on what would make it into state. And as long as that threshold is approximately the same as something like the existential deposit, it's safe. So yeah, asset trapper. After program execution, any asset still in the holding register, snapshotted into a storage item, indexed by the origin and the assets. And then as the claimer, you basically provide these information, which they get concatenated and hashed, and check to see if they exist. And if they do exist, it's removed. Oh, and also check to see that the origin is the origin of the claimer, of course. I'll just claim someone else's snapshotted assets. And if they are, then it gets removed from Pallet XCM's state and put in the holding register. Yeah, you actually have to present the asset itself, like what asset has been trapped. So you have to sort of check your program execution, see what was placed in the holding register. And there's an event, so it's reasonably easy, but you have to actually do that, and then and then this will check that the asset is correct and that the origin is as it should be, is the same origin as when it was trapped, and then it will give you the assets back, basically. And then you can do what you want with them, presumably either send them back to where they came from or deposit them in a local account. Good. Not too late either. So you should have a rough idea now of how the XCM palette sits between frame and the XCM XCVM. Yeah, how some of the basic usages like asset transfers and version negotiation is intended to be used, and it's specifically intended to be used by front end and runtime developers, not by their end users. Got a few, I said a few of the extrinsics in the XCM palette, which ones are useful. You've got an idea about how versioning works, how response handling works, and how asset traps work. Good. All right, any questions? Yep.
For doing something which involves querying on the other chain, and depending on that response, I have to do again something. How many blocks it will take on parachain A who has initiated? So
So this is if parachain A sends a message to parachain B, something happens, parachain B sends a reply back, parachain A then needs to do something else. I mean, this depends a lot on the message transport system. If it's a bridge, it could take a while, it could take several blocks. If it's like, I don't know, UMP, where it's just sending it to the relay chain, it's usually delivered within 1 block. So it would be 1 block to get there, it executes, sends back, 1 block to get back again, it executes. So you got a 2-block round trip. And then if you're doing it, say, another 2 times, because you need to do a query response, have a look at that, do something else, have a look at the query response that comes back, do something else. If it's this kind of 3-part operation, you're going to do talking about 6 blocks. In a UMP situation. If it's XCMP, then you can add an extra block delivery. So it's instead of being 6, it would be 9 blocks. Until there is a proper XCMP, it doesn't go via the relay chain, and then you can probably maybe get it back down to 6. I'll have to check.
Okay. So so the idea is like I'm building a product which talks on Asset Hub for information on asset, talks to identity related thing on a different parachain, and I mean talks to multiple parachains for one solution. That is not good idea then, because it will take a long time.
Well, it sort of depends. I mean, if you've got to be careful how you architect a solution, a scalable solution, like a parallel solution. And this is the case not just in blockchain, in general systems engineering, right? If 2 subsystems have a highly have a high degree of causal relationship, like if one acting necessarily results in the other needing to act, then you're not going to put them on very far away. You're going to put them usually so they can be synchronously composed, and then those actions can happen very quickly. Those reactions can happen very quickly. Okay. So if you have the option of doing this, because if you have the freedom to architect as you choose, then you bundle things together that need to be close to each other, and you let things go apart that don't, and then you sort of get the parallelism. You get the performance increase through parallelism, without the performance reduction through the increased communication latency.
Makes sense. Thank you.
Yeah, I mean, there's no free lunches here, and if you have to deal with, I mean, so suppose, for example, you're dealing with the collectives module, you're dealing with Asset Hub. It might make sense to start considering, if you're doing a lot of this and you're sort of constantly getting stuff through collectives, putting it in, doing some instruction in Asset Hub, and I mean, collectives is a pretty bad example, but like, I don't know, what can we think of? Okay, suppose you're deploying a parachain, right? And you want to do, it's maybe a DEX chain, right? And you're doing a lot of interactions with assets. Would you deposit and withdraw assets on Asset Hub in order to be used on the DEX? Well, no, you would probably not architect it that way, because one would assume that users are wanting to do this quite often, right? And if you force them, if your primary means of representing assets on chain is on Asset Hub, then it means every time they want to do a DEX operation, they're going to have to send an XCM to Asset Hub, withdraw the assets. That then comes back to the DEX chain, goes into a DEX, gets changed, and then another XCM back again, depositing the new assets. This is like very, very big pain in the ass. So realistically, you're going to optimize, and you're going to say, right, well, the assets that my DEX supports, I will just have a local representation of those assets, basically like an assets module or an assets palette or a tokens palette that sits actually on the DEX chain itself. and then users only move the assets over from Asset Hub once, do their trading, and then move them back when they're done and they want to do something else. Yeah, and then you've only got like 2 XCMs, but like only 2 rather than pairs of XCMs for every trade operation. So yeah, you do need to think about this a little bit when you're architecting. Yeah.
So my question is around the communication between the two parachains, especially the message conversion part. So as I understand that we can go from the higher XM version to the lower one and translate the message to the lower one to communicate and make the conversation go between the two parachains or two chains basically. But you also pointed in the case that if there are new instruction sets which are there in the XCM V or latest version, which is upgraded in the chain A, but not in the B. So in that case, it fails in the executor and it doesn't succeed, right? And so my question is like, how does like that chain B gets to know that that this message failed and not success, and is the way like then it gets to notified that now it needs to upgrade to the same message version as the A is.
It doesn't. The point of so one of the tenets of XCM, one of the 4 A's is absolute, right? The message is sent, there is something that happens, and that's it. There is no like, hey, try this and see what happens, and if I get an error back, maybe try something else. That's not what XCM is about, right? XCM is like, you do it once, you do it right. Yeah. You don't like spray out attempts and then see which one works. In the case of versioning, we have version discovery in order that if you have A and B, before A sends a message to B, it works out what messages B can interpret. And then it only sends messages of that version.
So kind of it's predefined, like A knows that what kind of message that B can translate, right? Because it is a lower version side already, right? So A knows that this is the message set that it can interpret, not the latest one, which is upgraded one, which cannot be interpreted by the on the B chain side.
Yes, so we have here. So please ignore the fact that this says XCM v2. This should say XCM v4. Someone didn't update the slide. It's correct otherwise. So chain A is at XCM v4. It has a registry of chains B, C, D, and E, and their XCM versions. These versions have been discovered either by manually, someone, governance or whatever, saying chain C is at v4, but more likely it's because it's used the Pallet XCM's version query and response. Yep, version subscription system. When chain A wants to send a message, now chain A is it's at v4, therefore its message is going to be in v4. Yeah, it will use XCM v4 XCM for its XCM type. When it sends such a message, if it's sending it to chain E, it will look at chain E and say, chain E is at version 3. Therefore, if chain A sends that v4 message, it will fail and nothing will happen. And the message there will be no return path. There is no return path in XCM. Yeah, it's asymmetric. Yeah, so it will not get hey, your message failed. The reason there's no return path, if it seems like a dumb design decision, is because return paths are expensive. We don't necessarily know, when we're talking about queues, weights, fees, we don't know that the return path will be as cheap or cheaper than the send path. It could be that the return path is incredibly congested and the message, the fees have gone up incredibly high. And there is no way of like getting that return message back in a reasonable period of time, or knowing even how much should be paid by them. Therefore, we can't easily provide a return path. Now, of course, we can say, well, look, if you want to manage these potential pitfalls yourself, then use stuff like query response, but be aware there are big pitfalls with just a blanket assumption of a return path. Such a big pitfall that it's not something that we assume. So there is no return path for things like error reporting by default, by standard. If you want error reporting, you have to do it yourself. And manage and answer the question of like, well, what happens if the queues are full? What happens if the fees are insurmountable and you don't have enough fees left, or you don't have any fees because the actual asset withdrawal failed because it couldn't decode the XCM? Like, at what point, how do you pay a destination chain that can't decode your message to send you a message back saying, hey, I couldn't decode your message? Like, it doesn't, you could spam someone with just crap they can't decode and spam up their sending queue, right? This is no good. So we end up with like big insurmountable problems when we do that. So we cannot provide it as standard. There are instances where you might be able to use it, but it can't be assumed. So what chain A does is it first consults. Chain E is at v3. Therefore, rather than send it a message for which I will get no response and will not do anything, I will first translate my message into a version that chain E can understand. Now, there is, of course, the outside chance that chain E upgrades to v4 after chain A has sent a v3 message, right? In this, like, while it's still in the queue somewhere or being transported or whatever. This is why chains conventionally support at least 2 versions of XCM. So that even if chain E upgrades to v4, it will still be able to read this v3 message and understand it. So yeah, XCM is all about actually making a message that works, like this whole measure twice, cut once mantra, right? You make a message that works before you send it, and you make damn sure it will actually do what you want. And we provide, through error handling facilities and asset traps, we provide means of like surviving in case you do get it wrong, but that shouldn't be the approach. The approach should be get it right. Measure how many fees are needed, prepare for the worst case. Don't expect it to, kind of hold your hand.
Thank you.
Any other questions before lunch?
Can I ask something? So how does chain A calculates how much fee it needs to send an instruction to chain E?
How does chain A calculate the fees involved with chain E? It used to be simple. It's quite a lot more complicated now. Basically, chain A has to look at chain E and see that there's actually, I think, 3 or 4 specific factors that involve that, at least if it's frames, Pallet XCM stuff, that will affect what the fees are on chain E. Like weight, there's a fee multiplier. There's something else as well. Can't remember what. You might have an asset exchange rate. You might not be sending in chain E's asset, so you might need to switch and pay for the asset that chain E charges its fees in potentially. Now you can query and work all of these out. At the moment, it's easy if you're off chain. If you're someone here that is asking chain A to send a message to chain E, and then in that case, you would just work out what those fees are off chain by looking at chain E, and then including them in with the assets that you're transferring or anything else that you're doing on chain E. If it's purely a piece of logic on chain A and it's not initiated by someone who can look at chain E and work out what those fees are, then it's harder. Then you need some sort of Oracle solution where the on-chain logic would ask the oracle, hey, tell me chain E's state, and then it would come back with those factors, and then it would calculate it on the basis of those and include those as fees. That oracle solution doesn't exist yet, and realistically, we will need something that is like XCM, but for read-only purposes to do that. And Notion, like this is something that will be put into development this year called XCQ. So it's not a thing yet, but it's the design is more or less done. And the idea is basically it's a language for creating and interpreting proofs, state proofs. So you can say, I want to know this about chain E, like these. And then it will say, given what I know of chain E, you have a sort of dictionary file for chain E that you might get over XCM, for example. Given what I know of chain E, you need to ask for these 3 state items. And then when you get the state items, they come back, you combine them, again via the dictionary, via the XCQ dictionary, and you get out a fee. And then that would be how you work the fees. At the moment, that doesn't exist, so you actually need to have some oracle, whether it's a part of the XCM sending machinery, like part of the UI, basically, part of the wallet or whatever, or whether it's sort of some service that you run that sort of feeds chain A with stuff to do with like the fee parameters of chain E. This is like, it's up to you as your depends on your use case and your chain. Broadly speaking, it's not really what you should be doing, but the fees don't change that much. You can probably just be very conservative and put some fee in that's like quite high, like I don't know, 3, 4, 5x what the fee is at the moment, like when you deliver some particular version of the UI, and just like maybe push an update in case the fees go up more than you would you expect, and then as long as you refund what's left from the fees, it should be fine. But really, you should be querying chaining.
So if I rephrase correctly, what chain A can do is pre-benchmark any instruction that it wants to execute and put some high limit, double or triple of that, and then that's reasonable way to do.
Wait, can I ask you this one question? Do you really mean execution fees rather than delivery fees? Because we're talking about delivery fees here.
Execution fees on chain E.
Okay.
But I mean, the chain A needs to have enough funds to even pay for the execution on chain A, if I understand correctly, right?
Yep. So there are two forms of fees that Keith mentioned here. So one of them is getting the XCM over to chain E. This is something that largely is looked after at chain A. And the other one is getting the message to execute on chain E. Now, getting the message to execute on chain E is one thing, but as part of message execution, there are actually 2 components. There is the basic instruction execution, and then there are things that the instructions might need to do that when they use system services, like for example, sending a message onward. Now, when you send a message onward, you're using quite a sophisticated system service. It involves message queues and potentially bridges and so forth. And this comes with its own fee structure. And this then gets a little more complicated as to how much more fees you include in the assets you're sending across to pay for not merely the execution cost, which is measurable quite easily by just looking at how much weight each of the instructions have and multiplying it by the fee multiplier, which generally doesn't change so much. And instead looking at the queue status of chain E, if it does need to do this onward transmission or bridge transmission, then you have to start looking at how much those are going to cost and adding that extra amount into the assets you're sending over. This is something that I think Keith is going to cover anyway at some point in the sessions, or at least I think it's worth covering.
We would at least be working on by execution. possibly that we don't really have exercises for transport layer stuff yet, but we'll get to that.
Thanks.
Anything else before we break? Nope. Good. Then in that case, that's me for today.